Hello everyone, this is Aditya and today we are going to perform Newton's Cradle experiment, and for that I have taken 4 balls and some ropes to tie them. And of course I am performing it at home, so it won't be that much ideal, but of course I will tell that much that you get at least the idea of that how the things are going, right? So let's perform this experiment, and first of all we'll start with 2 ball system, then we will go to 3 ball system, then 4 ball system. So first of all I will remove these 2 balls, I will place them somewhere a distance, and then we'll perform with these 2 balls, right? So let's start. So now I have kept these 2 balls aside, and now let's work on these 2 balls. So what I'm going to do is that I will displace this ball from its mean position, and I will let it strike this second ball, and let's see what we see. Okay, so I'm moving this, I'm displacing it, and now I leave it. Did you notice what just happened? Let me do it again. Okay, this is the ball. Did you just notice when I left this ball, when I left, it went like this, it hit this ball, the momentum was transferred, the linear momentum was transferred to this ball, and it went like this, okay? And it became stationary, and it went to some height, it again come back, and then it again hit it, and the series went on, right? But at last they started swinging together because the collision was inelastic, of course, because there's no collision that is 100% elastic, right? Okay, so that is the key concept over here. The whole momentum was initially being transferred to this ball, and now we are going to perform with 3 ball system. So now I've taken 3 balls, and now let's do experiment with them. Okay, so I will displace the first one, and let's see what happens. Did you notice what just happened? Let me do it again. And of course it is at home, so that is why the orientation of the ropes are not that much perfect, so that is why there might be some error in this experiment, but please ignore that. I will try to explain as much as I can, right? Okay, so let's do it again. I displace the ball, right? Did you notice what just happened? Let me show it again. Let these two come stationary. Yeah, what just happened? When this ball came and it struck the second ball, it remained stationary. The momentum was transferred to this ball, but the momentum was again transferred to this one, and it went like that. And it came back and it went like that. So the second was stationary, right? And this is all the beauty of linear momentum, right? Conservation of linear momentum, how the linear momentum transfers, right? Okay. So now let's take 2 balls at a time and let's see what just happens, right? Okay. Did you just notice what happened? Well, let's do it again. When I left these 2 balls, these two hit this ball, and they both went together, and this became stationary. And when it came back, again the linear momentum was being transferred there, and this became stationary, and these two went again. And this is the beauty of physics, right? Okay, now let's do with 4 balls. So now we have all the 4 balls, and of course you can take as many balls as you can, but for simplicity I've just taken 4 balls, right? So now let's displace this ball from its mean position and let it hit these balls. Did you notice what happened? Let's perform it again. When I left this ball, what will happen? Did you just notice that when I left this ball, what happened was that it hit this ball. The momentum was transferred from this one to this, then from this to this, and from this to this one, and that is why it went like that. And these two remained stationary, and of course this one also. And again came back. Again the momentum was transferred, and these three became stationary, and it again went to its extreme position, right? And of course if I perform it in vacuum, then this process will continue forever. But of course since over here there's an issue, that is why we can't perform it. Of course there's some loss of energies and everything, right? And of course the collision is not perfectly elastic, right? So we have to take those things into account, and then we have to work. Okay, now let's take 2 balls at a time. Okay, so we are bringing it over here, then we are leaving it. Did you notice when I brought these 2 balls over here? Let me bring them as at a stationary position. Yeah, now it's okay. So now let me leave these 2 balls. They both became stationary. When I left them, they both hit these two balls and they both went over there and they both became stationary. And of course, when they both came back, they both hit it and they both will again go there. Right? Okay, now let's perform it with three balls at a time. Let's see. Okay, okay, now let's leave. Did you notice what happened? Well, yeah. When I brought these three from their mean position to their extreme positions, this one, what happened was that when these three hit this ball, then the momentum was being transferred, and due to which this ball became stationary, and these three went to their extreme positions, and then again these three hit, and then they went over there. And of course, there's some orientation problem over here, so that is why it is not a perfect case. But of course, you all understood that what is happening. So I hope you all understood the experiment and you learned something new from it. Then please do like, share, subscribe my channel, and thanks a lot for watching it. Bye bye.